Okay, so let's do another example of phase shift, but this time we want to combine it with horizontal compression. Okay, horizontal compression. All right, let's have a look. So do you recognize it here? This right here is, okay, phase shift of pi over 6 to the right. This 2 though, right, will make the period 2 pi times by 1 over 2, so it's just pi. Okay. Now, make a special note about this. Sometimes a question like this can be presented in this way. Okay, I multiply this in, you get 2 pi over 6, so you actually get pi over 3. If it's in this form, where x has a number multiplied to it before subtraction, here we're subtracting and then you're multiplying 2 after. If it's in this form, you have to get it to this form to get the proper horizontal shift or phase shift. Okay, so a lot of students will go, oh, this looks like this roughly, so the phase shift is pi over 3 to the right, and that will be incorrect. And it's because, think about what number you have to plug into x in here to get sine of 0. Well, it's pi over 6, not, right? If you plug in pi over 3 there, do you see that that's not going to give you 0? The correct x value, which will turn the input of the sine into 0, is pi over 6. And that's correctly determined in this form. Okay, more easily determined here, not in this form. Okay, so now let's do the graph. Okay, so pi over 6. So pi over 6. Pi over 6, that's basically cutting up pi into 6, right? 1 out of 6 parts of the pi, right? Okay, so 1, 2, 3, 4, 5, roughly. This should be then 7 pi over 6, right? And this right here is going to be 2 pi plus pi over 6. It's 13 pi over 6. Okay, 2 pi plus pi over 6. That's 12 pi over 6 plus another pi, right? Pi over 6, so 13 pi over 6. So 1, -1, okay? Okay, so this will be the graph, right? This will be the graph if there was no 2, right? So we're not done. I just shifted it. So now let's finish it off by compressing it. So instead of finishing here, you should finish here, right? So the halfway point, okay, the halfway point should have been, okay, so let's actually do a proper transformation mapping here to make this really simple. So xy, because of the 2, we actually have to divide by 2, and because of the subtraction, we have to add by pi over 6. Okay. In a non-transformed sine function, the middle is pi when y is 0. If you want to know where this middle goes in the compressed graph, you plug it in here. So it's pi over 2 plus pi over 6, which is 4 pi over 6, right? 4 pi over 6. I write it up here because we can reduce this. It's 2 pi over 3. So 2 pi over 3, 0. Okay. So 1, 2, 3, 4. That's the middle, right? 1, 2, 3, 4, 5, 6. Oh, this is really not to scale here. That's why the graph looks a bit off. Okay, let me just redraw that here a little bit. So 4 pi over 6 will be there. And then 4, 5, 6, 7 is what it will end. Okay, so the graph will look like this. Okay, so this will be this graph here compressed. So sometimes it's hard to draw like the relative graph here, right? Because the scale is kind of hard to match. So what I would do instead is I would just roughly draw it out like this. I know it's been shifted and it's going to look like this. So I draw that first. I just label this as pi over 6. This is going to be 2 pi over 3. This right here, so where 2 pi should be, I use this here. That's where it should end, right? Before transformation. So if you plug it in there, you get pi plus pi over 6. That's 7 pi over 6. I just labeled that as 7 pi over 6. Okay, if you want to know what exactly that coordinate is, you plug in pi over 2, transform pi over 2, and you get pi over 4. When you plug in pi over 2, and you get pi over 4 plus pi over 6. Okay, and then you got times top and bottom by 3 here, so 3 plus 2 is 5 pi over 12. Okay, so this is 5 pi over 12, and that's 1, and this is negative 1. Okay. All right, so that's how we sketch, right, a compressed as well as a shifted graph. The tougher part is this, just getting these coordinates in fraction. It's kind of harder to deal with, right? This is probably the best approach. Graph the rough shape and fill out the details. All right, that's it for this one. I'll see you in the next.